So, are you ready? Oh. So the first thing we're going to do is talk about parabolas. Okay. So parabolas, they're really quadratics, and they're written in this form. But we can take that form and change it also into this form, which is called the vertex form. So this is the vertex form. This is standard form. So do you remember what a vertex is? Corner. In this case, if it's a quadratic, it's either the top of the parabola, which is a maximum, or the bottom of the parabola, which is a minimum. So that's the vertex. And it's always given by HK. So realize that in this form, the numbers they have right here, this H and the K, are your vertex. And if there should be an A right here. If that A is positive, it opens upwards. If that A is negative, it opens downwards. So if A is positive, it opens upwards. If A is negative, it opens downwards. So all of these are like symmetrical because they're parabolas and they're cut in half. So if I cut this in half, this dotted line is called the line of symmetry, and it'll always be the x value. So it'll just be x equals h, whatever that value is. So that's always going to be your line of symmetry. So that's in standard form, right? You remember how, or do you have any thoughts on how to get it to vertex form, the other way? Close. It's almost like what we did with circles. Remember we completed the square? But instead of adding it to both sides, we're going to add and subtract it on the same side. So it's like we're really adding 0, because you can add 0. So, but instead of dividing everything by 3, we're going to factor out the 3. So it's like dividing by 3. And the constant term, I'm not even going to bother with. I'm just going to move it outside of what I'm working with. This 3 in front, it's kind of tricky when we go to work with it here in a minute. So just remember it's there so that when we do the next part, you don't forget it. So half of 4 is 2. 2 squared is 4, right? So normally when we were doing circles, we'd add 4 to both sides. But remember how I said this 3 is on the front? We're not really adding 4, we're adding 3 times 4. So I'm really adding 12. So to make this so like I'm adding 0, I'm going to really minus 12 in here, or out here. So I've added 12 inside, I've minus 12 out here. So it's really like I'm adding 0. Because you can add 0 to anything and it hasn't changed it. That kind of blew me away in one of my college classes. We had to do proofs. And so we were adding and subtracting the same thing all the time. I'm like, why are we doing this? It's pointless. But anyways, so the reason is just to change forms. Okay, so we're adding 12, minusing 12. So this will now factor to be 3x minus 2 squared. Then out here we have minus 19.
Can you walk through why you got the minus 4 and plus 4?
Uh-huh. So I divided it, all of these by 3.
Right.
Which really I just factored it out.
Right.
So that gave me the x squared minus 4x. And then half of 4 is? And 2 squared is? 4. So I added 4 right here. So that was me adding the 4 inside.
Right.
But since there's a 3 out here, it's actually like I added 12.
Okay, I got you. That's
So in essence, what I really did is I added 12 and subtracted 12.
yeah.
And then when we complete the square, it's always going to be half of that, whatever half that middle term was. So x minus 2 squared. So the vertex is where? Positive 2. So it's always backwards of the sign inside. Does this open up or does it open down? Up, because the 3 is positive. So since it opens up, this therefore is a minimum. So I know it's going to open up like this. What's going to be the lowest y value? Yeah, so that's negative 19 is your lowest y value. So when you're talking about range, it's going to go from negative 19 to infinity. The domain on these is always going to go left to right forever. So negative infinity to positive infinity. Is this going to cross the x-axis? Since the y value is negative 19 and it's going upwards, it has to cross the x-axis somewhere, 2 places. And it's most likely going to cross the y-axis as well. So to find the x-intercepts, you would just let the y value be 0. So I'd have 0 equals 3x minus 2 squared minus 19 to find the x-intercept. Then I'd add 19 over. Divide it by 3. So 19 over 3 equals x minus 2 squared. So square root it. So this plus or minus the square root of 19 thirds equals x minus 2. So then I just add that 2 to the other side. And that would be my x-intercept. And you can type that in your calculator and actually get a value for that. To find the y-intercept, you would just let x be 0. So you'd have f of x, which is y, equals 3, 0 minus 2 squared minus 19. Negative 2 squared is 4. Times 3 is 12. Minus 19 is negative 7. So the y-intercept is negative 7. So on all of these problems, you're supposed to write the function in vertex form, determine the x-intercept, sketch the function, determine the minimum or maximum value, identify the vertex, which we've done, determine the y-intercept, determine the axis of symmetry, write the domain and range. So everything that we've done on this is what you're supposed to do on these problems. What's the axis of symmetry? We didn't do that one. So x equals 2 is our axis of symmetry. So that's what we're working on today. There is a shortcut way to find the vertex. I've never taught it, but I'll tell you guys what it is. I've always just done completing the square, but it's easy once you remember this part. So if I had, let's start with the same equation, 3x squared minus 12x minus 7. So to get the x coordinate, it's always going to be negative b over 2a. So I'm going to take negative 12, and that negative's already there. So that's 12 over 2 times 3, which is 6, which is 2. So see on our last problem, the x part of the vertex is 2. So now to get the y coordinate, the y value of your vertex, you plug this value back in for your x's. So 3 times 2 squared minus 12 times 2 minus 7. 2 squared is 4 times 3 is 12 minus 24 minus 7. So negative 12 minus 7 is negative 19. So the x coordinate, to recap this, the shortcut way is to take negative b divided by 2a. And then to get the y value, you take your x coordinate and plug it in, and that gives you the y part of the coordinate. So it's all by completing the square. We could walk through how the formula is derived, but it's just completing the square of the quadratic, that ax squared plus bx plus c. So if we complete the square of that, it gives you this. So anyways, that's how that comes to be. What else? Some story problems. But they're just using this information. And then tomorrow I'll teach you how to use your calculators to do a quadratic regression formula. That part's real easy. You type it in your calculator, hit enter, and it does all the work, and you write down the answer. So there you go. Does it open upwards or downwards? How do you know it opens up? Yeah, because that half is positive. So it opens upwards. So that's the first question. Part B, identify the vertex. Where's the vertex? Negative 2, 0, because it's always backwards of that sign inside of there. Part C, determine the x-intercept. So the x-intercept is when 0 in for y, right? To find the x-intercept. So now I solve that. I'm going to divide by 1/2 or multiply by 2. It's the same thing. So 0 equals x plus 2 squared. So now I square root that. The square root of 0 is still 0. So looking at our vertex, if our vertex is at negative 2, 0, that means our parabola starts on the x-axis. So that's why there's only one x-intercept, because that's where it starts. So anyways, that's part C. Part D says determine the y-intercept. So that's when we just let the x be 0. So y equals 1/2 of 0 plus 2 squared. So 2 squared is 4. Half of 4 is 2. So the y-intercept is 0, 2. We're going to save E because it says sketch the function. F, determine the axis of symmetry. X equals the vertex value. So x equals negative 2. So that's the axis of symmetry. So whatever our x value is on our vertex will always be the axis of symmetry. G, determine the minimum or maximum value. Since this opens upwards, we know that the vertex is a minimum. So the minimum value is at negative 2, 0. And the minimum y value is 0, right? So the minimum occurs when x is negative 2 and that value is 0. H, write the domain and range. So the domain, this thing goes to the left forever and it goes to the right forever. All your quadratics will always go left and right forever, unless they have some rule that makes it stop, like only use x is greater than 0 or something like that. The range, since this opens upwards, the bottommost y value is 0. So it goes from 0 up to infinity, and it's a bracket because we do include 0. So that's what the first 8 problems look like. So to graph it, you go to negative 2, 0. You go over here to 0, 2, put a dot there, put a dot. Because we know it's symmetrical, if I go over here to and up to, there's going to be a dot there. So there you go. It's sometimes easier to pick like a point on each side of the vertex and figure out the y value so you have an idea what the first few points look like. Or you just type it in your calculator. So